Okay, so I'm going to start 30 seconds early because I have, this says 88 slides, but it's really kind of more. Just so you guys know, the way that this is going to work is, the way I planned it is the first 20 minutes of this is sufficient for beginners and also a refresher for everyone else. The last 20 minutes is way more in-depth stuff, some non-core DBIx class modules, and some neat tricks, and how different parts of DBIx class works. So this is the contact info for DBIx class stuff. Oh, let me just show you. All this stuff is on the internet. All these slides. You can either go to this long URL or bit.ly/dbicprez. So bit.ly/dbicprez. And that'll take you here. So if you ever want to refer to these slides, there's links for almost all the documentation of everything. If you want to leave and go see Chromatic Talk, I'll be okay. But I'd rather you be here. So I wrote these slides. How many people here have used any ORM? Lots. Okay, how about like some of these non-DBIC ones, Class DBI, Rose, Faye? Okay, so a few, maybe 20%. How about non-Perl? Okay, so about 10%. Cool. Well, I'm supposed to show you as many features as I can to make you know that DBIx class is awesome and how to use it. Okay, so what is DBIx class? It's an ORM, which about all of you know what it is. So you can use SQL to make objects, all this stuff. There's lots of them. DBIx class is the best, objectively. So these are reasons that aren't technical or inherent to DBIx class. This applies to almost all ORMs. There's a big community for DBIx class, so we've got like a lot of contributors that help with things. The most recent release. Did you say something? Sorry, I thought someone said something. The most recent release, which is actually still a dev release, has 8 new features, 26 bug fixes, and some miscellaneous things, and that ebbs and flows. I needed order by support in Microsoft SQL, and they helped me add the support. They were very welcoming. I think it took a total of like 2 weeks, and now it would be faster because I know the code base. Sorry, what I said before about meta applying to all things, this next stuff is those things. So, all right, cross-database. This is awesome. I love the fact that I can write code with DBIx class that runs in SQLite for development or SQL Server for deployment or Postgres or MySQL. It's very rare that I write specific database code. Usually that's date handling or whatever. Basic CRUD. This is I'm just gonna go over DBIx class versus raw DBI. And if you don't know what CRUD is, that's it. Create, read, update, delete. So create. We've all seen this before. This is DBI. Can you see my mouse? Yeah. So you prepare and you say what your values are going to be, and you do the execute with the actual values that are going to go into there. And then with DBIx class, you don't have that having to match the question marks and all that stuff. So that's kind of nice. That would be a link to the docs for create. It automatically grabs the ID that was auto-incremented for you. If your database supports it, it'll use insert returning, but whatever, who cares? The point is that it gets back the object and its ID in one fell swoop. For reading, this is typically how one would read things with DBI. Here, you do your prepare and you iterate over a iterator that you get from that. I don't think there's an execute, and there should be, so there's a bug here. With DBIC, there's lots of ways to do it. So here we're just saying, I want to find this one book, or here I want to find a single book with this title, or I want to find all the books that have such and such an author ID, and then I want to iterate over those. Again, docs. There's more than one way to do it. So you can do all these different ways to do things, and it's fairly succinct. It's fast. It works well. So. For update here, you've got your standard SQL update stuff, and then with DBIx class. Note, we don't have to deal with the ID. That's another thing. So the cool thing is, I don't know if you guys have ever done this, but if you leave off the where clause on an update like that, like you've like blown away all your data. So you're safe from like stupid mistakes like that with DBIx class. Also, update is lazy. So if you called update on something like this and the title were already new title, you'd be fine. It wouldn't even do anything. And then delete is, of course, obscenely simple. It just calls delete. So here's some examples of SQL Abstract, which is the query language that DBIx class uses. Here's SQL. You can all recognize that. We're saying like Monte Cristo, and the topic is jailbreak. With DBIC, you use this SQL Abstract thing, which is hashes and arrays and other things. The docs are at SQL Abstract. For the most part, it's kind of introspectable, so it's easy to generate these, like from, say, a query or something like that. And by query, I mean like a CGI query parameters. But it's not quite introspectable. Anyway, it's awesome. It's better than everything else. So one of the cool things you get with ORMs in general is OO overrideability. So you can override new if you want to validate that someone passed something. You can override delete if you want to say you can't delete these things at all, ever, etc. This is not quite 100% true. There are things that we don't get from straight, OO with like a Kyoku or something like that. But it gets us pretty far. So it's still really handy. There are a number of convenience methods that most ORMs give you. One of my coworkers actually thinks like these two methods, finder create and updater create, are the #1 reasons to use DBIx class. These two methods right here. So I'm not so sure, but whatever. Here's an example of other methods you can add to a row with almost all ORMs. So here, like, we have a user and we want to give them a gravatar URL method. Now we can just do, I don't have an example, user arrow gravatar URL, get their gravatar. So that way you're putting that logic inside of the object and it's all nice and abstracted away. Relationships, these are big. There are a number of them. There's belongs to, has many, might have, has one, and many to many, which is not a rel. I'll explain those in order. Belongs to is when you have the ID of another class in your row, or another row in your row. So you're saying, yes, I belong to that row, and here is their ID. Has many is the other way around. So you're saying there's a bunch of rows that have my ID in them. And a bunch could be 0 to infinity. Might have is 0 or 1. Other rows have my ID. So basically, I can't think of a good example of might have. But, so you could say, like I have one drink, might have one drink, so you have one or you don't have one. The point is that they have your ID in them. Everything is they have your ID except for belongs to. Has one is there's exactly one. And many to many is a way to go through a relationship to, say, like a tag system is typically many to many. So there's many tags and there's many authors. There's an intermediate table that makes it so that authors can have many tags and tags can have many authors, many to many. But it's not a relationship because it's not one join. So the cool thing about relationships is you set them and forget them. Mostly, once you've got them there, you can just use them by name. You don't have to think about how they work like you did before with raw SQL, with joins and on clauses. So that's a really nice thing. And actually, you can change them later to just change your database, but not have to change all your code. So extended relationships are relatively new. They are a way that you can do more than simple equality with joins. This is something that DBIx class hasn't had up until, I think, a year and a half ago. So here, basically what this is saying is it's kind of noisy because it does complex things, but we're saying the other table has to have a user that's the same as my user, and it also has to have the shared bit set. This is actually from some of our code at work. And the reason that there's the this second return here is there may not actually be a row object, and if there's not actually a row object, like for instance you went from one result set, did related result set, and then another related result set, it would use this SQL right here. This is actually not going to use a join, it'll just use a where clause. If you don't know what that means, you can even leave this second part out, but it's just a performance thing. So, okay, deploy. Deploy is, it uses SQL translator, which I don't have a link to take your schema and run all the DDL that you used to have to write by hand to create the schema. So it's really handy. It's really good for like like when you're mocking up the project initially, you don't have all the DDL and all the indexes and all that kind of stuff. You just say deploy it to SQLite or deploy it to MySQL or whatever, and it just writes the DDL for you, and it's just handy. If you want to use something more extensible, which I'll talk about later, you can use DBIx class deployment handler. Schema loader goes the other direction. It parses, or not quite parses, it queries your database and the information schema to generate a DBIx class schema from your database. So if you've got like a legacy application and you're going to switch it to use DBIx class, use schema loader. It's really handy. Some people actually only modify their database and use schema loader on a regular basis. Okay, I don't really like that idea, but whatever. To each his own, right? And loader options is where the real docs is, and I felt like you really need that link. Populate is a handy thing for inserting a lot of rows quickly. One thing to point out here is Populate skips all row creation steps for speed, and so here we're clearly putting our password into the database as clear text because unless you've overridden Populate or something, it's not going to go through your hashing stuff, but it's very fast. I used this at one point to export a whole SQL Server database to a SQLite database fairly quickly just so that I could use our code on my laptop. And it worked great. Multicreate is a really handy way to take advantage of your relationships to create complicated things. So here we're creating an author, and we're also creating his books and his address if it doesn't exist. So, obviously his name is Stephen King. Here we've only listed one book, that's The Dark Tower, and we've listed his address. I'll show you in 1 second. I didn't list books. So the thing is the way that these things work is you define unique constraints. So like for city and state, for the way for that to work, you have to say the abbreviation in state is unique and the name in city is unique. And if DBIx class knows that it's unique, it'll check the database first. So you tell it, hey, the title of a book is unique, which isn't really true. But if we could pretend that it were, that would take care of that for you. For something like this, where books have the same name all the time, you might consider making a unique constraint on title author ID, because I think it's pretty unlikely that an author is going to publish the same book multiple times with the same title. It's possible with multiple printings, but you can have DBIC not create it if you define the right unique constraints. Does that make sense? One thing to notice is that books is an array ref, and that's because it's a has many, and address is a hash ref, and that's because it's a belongs to. So because books has many, you can fill many in there. If you accidentally make it a hash ref, it will not work the way that you want it to. It'll probably say that's not a column. DBIx class is very extensible. It helped pioneer fast multiple inheritance in Perl 5 with class C3. So extensions are everywhere in it, and we'll talk about that a little bit later. So here's a common pitfall that new DBIx class users constantly run into: result versus result set. They are not the same. Remember this. A result is a row. It's not necessarily a row in one table. It could be a row in that includes joins and stuff, but for the most part, it's just a row, and usually it's a result object. A result set is a query plan. It's not a table. It's not a whole table. It's the data that you're expecting to pull out. So, and it's not pulled out yet. So if you call search, you haven't gotten the data yet. All you're doing is winnowing down the stuff that you're planning on getting. So if you say search rows 1, comma, or rows 5, you're saying I want the first 5 rows from this database. If you say search name Frew, you're saying I want the things that have a name of Frew. But until you've called certain methods, you're not getting that data back. So it's lazy and it's intelligent in the way that it's just a plan. Also, this is kind of neat. It has an internal join optimizer that works on all databases because we have extra metadata. So if you try to join in like 10 tables or something and you only search against one of them, we'll prune those other 9 for you. That's better than any other database can do, by the way. These are less important, especially if you're new to DBIx class, but I should mention them. The result source, which you might see here now and then, is usually a table, could be a view. And the storage is pretty much your database. Okay, ResultSet methods. I think ResultSet methods and ResultSet chaining, which I'll get to in a second, are the single most important part of DBIx class. So if you take nothing away from this talk, please at least remember to Google this or something. So here we've got a result set of books, and we're saying I want to make a method called good and a method called cheap. The method called good says that we have a rating of greater than or equal to 4, and cheap says we have a price of less than or equal to 5. This current source alias thing I'll talk to you about in a second. But basically the idea is you can say books arrow good to get good books, books arrow cheap to get cheap books. All of your searches should be result set methods. Now, I know that's that's a bitter pill. It's tough to actually do that. But once you implement your schema that way, you can really reuse and test a lot of things that you probably couldn't before. The name has an obvious meaning, so that's helpful. And then the current source alias that we had before makes things matter no matter what angle you come at that result set from. So if you just do straight schema arrow result set books arrow whatever, that's pretty naive and obvious. But if you do a related result set, so you go through another join, the current source alias will make sure that that works. So when you make these, at least use current source alias or the helper that I will mention later that has a shorter name. Okay, so here's some examples in action. So here we're saying I want all the books that are good. Or I want all the books that are good and cheap and recent. So this hasn't hit the database yet. It's just making a plan. Obviously, we didn't define the recent method, but you can all imagine what that might look like. Got some date stuff in there. But basically, here we're finding all the books that match all of these queries. Easy. Here's an extremely complex example that's actually from my work of use of search related, which I've mentioned a couple times before. Basically here, we're going to the user result set. We're saying I want to find the one that has a user ID of Frew. We're going to go through his access table to get his MGMT table, to get his orders table, to find the telephone orders, to find the shops that have a date completed between these 2 days that are completed, and then go through that to the RPT score, grab just the raw scores column and get the first one. I couldn't actually get the sequel for this because I ran out of time and my laptop had a beverage accident. But this is brand new, that's why it's Windows. But this is like what? 1, 2, 3, 4, 5. There's going to be 5 joins in there. And it's changing the angle of what the initial from is every time you do search or related result set or search related, which is just a shortcut. But search related is awesome, and once you grasp it, your life will become awesome. Okay, I'll talk about getColumn a little bit next, or in a bit. Bonus relationship methods, these are just handy things. When you create a related object, you can either use create related, so you're saying I want to create related books, or you can use add to books, which is just a shortcut that does the same thing. Just handy little methods that save you time. Again, obviously this fills in the foreign key for you. That's nice. DBIx class has excellent transaction support. You've got schema arrow txn do, which takes a code ref. You've also got a scope guard type thing. Both of those methods will auto rollback if you die for whatever reason. The low-level txn begin and commit exists. I have never used those, not once. I don't know why you would. I would say you probably shouldn't, but they're there. txn do has one strange caveat that if you lose database connection, it will rerun that code ref. So be careful what you do there. Like if you were to, like, I don't know, print out something, it would not. It would print it twice, possibly. Okay. Inflate column is a handy way to inflate columns into objects. So the common use case here is date time, because everyone uses timestamp or date time columns. And actually, as I note at the bottom, DBIc or DBIx class, inflate column date time, does this automatically for you for every database, and it works great. So I just kind of made a little stupid version here just to show you how it works. So you guys can do this yourself for whatever other objects you might store in your database. And then here's a use of deflation. So we've said date published is now, and then we want to call update on that. Or, you know, date published arrow month abbreviation, and we get that abbreviation. Filter column, we actually wrote that, my company, for unit conversion. So you might want to store everything in imperial or hopefully metric and then show everything in the application as, you know, the other. So here we've made methods that convert from one to the other. You don't have to use actual methods. You could use a code ref here, but the idea is you can override it if you use an actual method name. And there's plenty of documentation on that. Result set column. That was the get column that I called before. If you call get column, see, this is one of those places where people get confused about rows and result sets. If you call get column, it'll work on both of them. Get column from a row will give you the private data for that column. Get column from a result set will give you a special object called a result set column, which has all of these nifty little methods. So you can say, I want the first column, all of the prices, I want the minimum price, max price, the sum, whatever. There's also a func so that you can say func and average if your database supports it. This is awesome. You can get aggregate data with DBIx class fairly easily. So here we're saying I want to get all of these things that have a price, and I want to group by the price and genre, and I want to find the max price and the average price. So basically we're saying what is the max and average price for each genre. And there should be quotes around that. Here we have to use get column because there's no accessor, whereas there is an accessor for price and genre. Like I said, get column can mean a number of things. It can either mean private. So for a row, if you call get column, you probably should just be using the accessor that was installed for you. It could be public for what I just used it for, to call max price or whatever, because there is no accessor. Or it could mean get the result set column. So keep that in mind. Someday we have to change this. It's the worst. Href inflator. It is a result class. That's the full name of it, obviously. It's really small in memory because instead of making objects for each row, it just makes a href. It's super fast. It's great for debugging. I often use this in little workbench things to see what data I'm getting back. And it's super, super good for performance. So like we actually had a table that was taking 2 minutes to get all the information out of, and it went to under 3 seconds once we switched to this. We have Subquery Support. We've actually had this for a while, but people don't use it very often. So here we're making an inner query where we're saying artists that have a name of Billy Joel or Iron Maiden, get the ID column and make that an as query. So as query says turn this result set column into a query object thing. And then here we're saying I want to find all the CDs that have an artist ID in this list. You should be using a join for this, but whatever. Okay, bare SQL with placeholders. This is bad. Don't do this. The user could have typed in some SQL there and you could get in trouble. So here instead we can actually do placeholders. And there's optionally some more type information that can go in here that is completely undocumented. But anyway, yeah, just do this and you should be fine. Okay, these are advanced. I stole some of these slides from the tall man in the back who just walked in. So, yeah. And also, my laptop is much wider than this screen, so we're going to have to scroll some. It's kind of a hassle. So, here's an... It's really too bad that it's... Hold on, let me see if I can zoom out to make it... That's kind of okay. So basically, this is us actually using DBIx class to do really complicated SQL. You can read over that later and see if you can piece it together. But the point is, you can generate intense SQL like this. So just a cool example of one of the things you can do. DBIx class is 4 basic loosely coupled abstractions. There's the query definition manipulation framework, so that's the result sets. The storage, which is the storage layer, which I called the database earlier. You've got your relationship model abstraction, and that's every time you add a relationship, like we said before, it actually goes into the result source, which we talked about as kind of like a table or a view. And then you've got the result parser, which can be the row, href inflator, which we talked about, or something else that you could define yourself. And I'm going to skip that because we're going a little fast or slow. Okay, so where are we? Okay. So one of the things that typically confuses people in DBIx class is, we haven't even talked about prefetch. Prefetch is like join, which is a way to join in other tables or whatever. But it also pulls it down with the stuff that you're selecting. This actually inflates to this monstrosity-ish, where you're saying, I want to load the CD's title row or cell into the CD's.title inflation spec. Similarly, tracks.title goes into cd.tracks.title, which is confusing, and I recommend you look at the output of href inflator to kind of get a feel for what that means. This actually has had work on it recently, which I don't think is merged, but I'm not sure. It has? Okay. So it will be in this release that's in limbo right now. Result sets can do a lot of the CRUD that rows can do, with the caveat that if you've overridden delete or update in the rows, you probably need to do the same thing in the result set if you want to take advantage of that. But if you just want speed, don't. So here, you could call, like I said before, populate to quickly create things, update to quickly skip the update step of updating each row at a time. You update the whole database with a single where clause, and then similarly delete. You can also use rs, arrow cursor, arrow next, or all to directly grab the data from the database that would get passed to the result class at inflation time. I've never done this, but you could do it if you want the speed of it. Okay, and then this is something that I think that people don't realize that DBIx class does. How many people here use ODBC? Okay, like very few. So people think that they can just ask the database driver what database they're connecting to. Well, the problem is that that works for MySQL and Postgres, but if you're connecting through ODBC, that could be anything. That could be Microsoft SQL, that could be Sybase, that could be Postgres, that could even be MySQL because it can connect to all those things. DBIx class abstracts away a lot of those problematic things when dealing with DBI, which is crufty and poorly specified for some of these stranger things. So, it handles holding the DBH for forking. It does transaction stuff consistently. It will generate your SQL correctly for each whatever database you've actually connected to. So it's awesome. Some of us are kind of working on taking it out of DBIx class so more people can use it, but that's a very painful process. Okay, so you can write your own result classes. So you've all seen href inflator, or at least saw what I was talking about with it, it's not difficult for you to write a result class that would inflate to a moose object or a moo object or whatever you wanted. Personally, I would say it'd be better for you to make your moose object hold a DBIx class row object, because you're going to have to re-implement, update, and delete, and all those other things. But if you want to, you can. Okay, we talked about extended relationships a little bit before. I just feel like I need to mention they're just a code ref. So you could warn if like people were using deprecated relationships, or use dynamic scope to have parameterized relationships. But really, you can do whatever you want because it's a code ref. So that's a really cool thing that I think that probably no one has taken advantage of yet. So not that I know of. Okay, so DBIx class components. I say not me, these are lots of authors, but actually I did write all these. So Candy. You should all be using Candy because you don't want to get carpal tunnel. This is what it looks like when you use Candy. You don't have the __ package yelling at you. The rest of the examples will use it because it actually makes the slides smaller. Okay, I didn't write this one. All right. Timestamp, it does the date time set on create or set on inflate for you, or set on create or set on update. I ran into a bug in date time because of this, but that's probably just because I'm using sub-second timestamps. Encoded column, I didn't write this one either. Okay, good. I'm a liar. So use this for passwords. Use this exact config. You might want to increase the cost, but aside from that, you will make safe hashed passwords in your database. And it works great. Just a detour. If you're new to Perl and you don't know what context is, this is an example of the use of context. I hate it. If you call search in array context, you get all of the rows in the database. If you call it in scalar context, you get another result set. But the problem is, if you pass search into a method, that's list context. So now you've passed the whole database to that thing. I hate it. So I wrote this helper, which you can't see the whole name of, called ignore want array, which lets you just do the right thing. You have to call all if you want everything. I like it that way. You should all be using this. On column change. This is a handy component that I made to automatically do something when a column changes. It's kind of an involved process to do that with direct.oo because DBIx class update can take parameters, or you could have used the accessor. Just use this. It's really handy. Set operations. This is a horrible example, and I don't know why I didn't fix it. This is a real example, though. This is the only way right now to use unions with DBIx class, and I need to use unions fairly regularly. So you should probably at least check this out to be able to use set operations. Relationship dwim. I hate typing the full myapp : schema : result : whatever. So I made this relationship dwim thing, which will do the right thing if you just put : in the front. So look how short that is. Storage values. This will let you keep track of the value that was in the database before you called update. So here we're putting a log method inside of update to have the old and new value and logging it. This is mostly important because it is used in on-column change because you get the old and the new. Subclass. We use this at work. I'm mostly happy with it. It's a weird thing. Basically, it lets you subclass other results and include the relationships and other things that don't normally come with the subclass in DBIx class. You can use class C3 componentized to do what this does now, but no one's done it yet that I know of. ToJSON, this just generates a handy ToJSON method for you. I made this recently. This is the ResultSet correlate relationship method, which I have an example for later. But basically, if you don't know what a correlated subset is, or correlated subselect, it's a way for you to, or what I've used it for, is to get aggregate data without a group by. So you can say, I want the average price of all these things, but you have no group by. which is just great because you don't have to manage that. And also you can do certain things like I want to get all the prices that are over $5 and all the prices that are under, or the average over 5, average under 5, and you could not do that with a group by that I know of. So this is awesome. I'll show you the slide later. Search or is a thing that I made recently. If it's not clear, searches are additive. So if you do ResultSet arrow good, arrow cheap, you're getting the books that are good and cheap. But if you want the books that are cheap or good, you can either write a new ResultSet method, use search or. So like here, we're saying artists that are touring and they have a record label. This is saying artists that are touring or have a record label. Or you could use a union, which is often overkill, but sometimes you just have to. So the cool thing about search or is that if your artists RS is like the artists that already have some criteria, this won't accidentally get artists that you didn't ask for. So like if you'd used a union and this part right here were not artist RS but schema ResultSet artists, you would accidentally get much more artists than you were asking for. Schema lint contents, this is just handy if you are in one of those shops where they're like, you can't use foreign key constraints because they make things slow. So you can use this to actually find things that violate the constraints very quickly because it uses correlated result sets. So yeah, duplicate PKs and unique constraints, broken foreign keys, and it also checks for nulls because when I wrote it, we had a database that accidentally had non-nullable or nullable columns that should not have been nullable. Result class dwim lets you type : HRI instead of or DBIx class : result class : #ref inflator. MST does not approve of this, but I still like it. Remove columns. This is a way for you to specify the columns that you want to remove from the selection. So often, like for example here, we're saying I want all the columns that are default except for password. So it's more robust for if you add columns later, and it's also less to type. So it's handy. There's also an auto remove columns, which, does anyone here use that? I hope not. Okay. It has some problems. So I'm ashamed. This is a handy helper that basically generically says I want to get a random row from a result set. So it works for every database. People say it'll be slow in MySQL, but no one's given me any timing on that. So I'm just going to assume you're all wrong. Writing join tables, I think, is often a lot of drudgery. So I made the join table helper, which basically lets you say the class on the left, the class on the right, and the method to use, and it automatically generates the relationships, the primary key constraint. It uses _ID for these the rows that it generates. You can specify more if you want to, but typically it's just going to be those 6 lines. Deployment handler, generates the DDL with SQL Translator. You can run Perl and raw SQL for migrations safely, which I'll talk about in a second. And I'm going to show you an example. And John Napierkowski isn't here, but he wrote a thing called DBIx class migrations, which is on top of this, and apparently makes it much more easy to use. So you might want to look at that too. So that's weird. Okay, so here's just an example of using DBIx class deployment handler at work. So here we're actually using schema loader to get the schema, because as you change your schema, it may not work. Oh, anybody know how to do that in Vim? I don't.
You have to change the putty setting.
It's not putty. This is Vim. GVim.
Oh, you are in G.
Yes. Yeah, I tried that. Sorry.
I think it's set GUI font.
Set GUI font
GUI font
equals, and we'll say 18. Awesome. Okay. So that's a little silly. Anyway, so here basically the cool thing is this is using schema loader to load the current schema from the database because you don't want to use the schema that's actually in your source control because it's not the same as what the old migration was. Because the migration might be from 5 years ago. You're genning up a new database and running all the way forward. This happened to me. This just works. But yeah, so here we're doing all these things to put fields back in the database that accidentally got deleted, and it just works. And then also, just if you care, raw SQL that you can run. So that's cool. This is a kind of a pattern that I invented with the help of that tall guy back there again. So here's us using correlated relationship in action or whatever. So what we're saying is we're making a method on our result set called with all computers count. It adds to your inflate spec a column called all computers count, and that uses a subquery that grabs all the related computers, counts them, and makes it a subquery. I don't know why I lost my syntax highlighting. Anyway, so the method name should be obvious. Basically, you're saying, I want to select this thing and include the column counts. Then, if you use this new helper called row proxy result set method, you get that in your row. So you can call all computers count, and it will either go to the result set and call it again, or directly use it from when you called with all computers count previously. So the point is, it's very efficient if you've already called with all computers count. Otherwise, it'll go to the database and get it for you. If you don't understand why this useful result set methods thing is really handy and a big deal, come back to this after you've used DBIx class for a couple months. And I hope that it'll be obvious to you because, oh, and there should not be a fat comma there. Sorry. Anyway, that is it. Any questions?
How does the performance on DBIx class compare to just using DBI directly?
It really depends.
Repeat the question into the microphone.
Thank you. He asked, how does the performance of DBIx class compare to raw DBI? It really depends. I have found that people who write, some of my older projects have really bad SQL in them, and DBIx class does better because they would generate bad join clauses and things like that that would accidentally grab like Cartesians and stuff like that. If you're talking the exact same queries, DBIx class will be slower for huge amounts of data, but if you use href inflator, we've actually seen cases where DBIx class beats DBI because we use direct things that you're not going to use by hand because it's a big hassle. So it does really well with speed.
How do I get started? If I keep avoiding going.
Okay, so someone asked how you get started. I would say it would not be a bad thing. Okay, so if you want to learn on your own, everyone has like little idea. Like I have an application that I store mixed drinks in, and I use DBIx class to define the schema. So you could start off making your own schema. On the other hand, if you want to start off with a huge example, you could use schema loader to load your schema for whatever you use at work, and that'll generate a fairly large schema of everything in your database. And that's a handy way to get started, I think. Does that answer your question? Okay. Any others?
And when do we get NoSQL support?
Oh, okay. So someone asked, when do we get NoSQL support? And let me just, I have to point out one of my slides real quick. So
Without giving up on this.
Oh, that's what I was going to say. Okay, well, yeah, giving up is using NoSQL because I feel like once you stop using a relational database, you're just giving up. And I'm not a fan of NoSQL because I don't get the point, but whatever. So I don't really know if that answers your question.
Yeah.
Right. People think that they need NoSQL, and they're like, oh, yeah, this will solve all of our problems, and it just creates the same problems, the exact same problems. So there's probably another talk about how awesome NoSQL is, but that's not this talk. You'll notice on my badge, I don't know if any of you probably can't see this, but I have the NoSQL tag, and it has a circle and a line crossing it out. Okay, well, I think we're done. I'm not positive.